My name is Ahmed Abbasi, and I'm going to talk about our paper titled Constructing a Psychometric Testbed for Fair Natural Language Processing. We have a fantastic author team for this paper. In addition to our collaborators at UVA and UST, I'd like to acknowledge three of my colleagues from the Human-Centered Analytics Lab here at the University of Notre Dame: David DeBoye, John Lawler, and Kendall Smith. So psychometrics is the field of study concerned with the measurement of individuals' attitudes, personality traits, perceptions, and knowledge and abilities. In social science research, psychometric dimensions are latent constructs that are known to be important antecedents, moderators, mediators, and consequents for humanistic behaviors and outcomes. For example, constructs such as threat severity and response efficacy are critical psychometric measures that affect one's likelihood to avoid security threats. In behavioral health, psychometric dimensions such as trust in physicians and anxiety visiting the doctor's office are known to affect future physician visits and all-around well-being. In e-commerce, satisfaction with a website's design is correlated with purchase propensity and customer loyalty. Similarly, many individualized financial behaviors can be partially explained by financial literacy and psychological traits. So we know that psychometric dimensions are important. The primary modes of collection involve surveys and interviews. Rigorous data collection protocols and best practices have been developed over the years. For instance, here's an example of survey items for patient trust in a physician. We can average these responses across the 5 items to get a single composite score. While these techniques have many benefits, such as measurement control, they also have limitations. First, primary data collection through an administered survey can be time-consuming, often 20 to 30 minutes of time needed. Second, such primary data collection cannot occur in real time. Most surveys and field studies are conducted periodically at monthly or quarterly intervals. And third, while surveys are a rigorous form of data collection, they are limited in their ability to account for data outside the predefined measurement framework. So the big question we are trying to answer is, can we estimate psychometric constructs via text? And of course, there's also some fairness implications to this that we'll talk about. So can we score trust in physician, for example, from user-generated text such as the following? To do this, we've developed and tested a testbed construction method where users provide their survey-based responses, which we consider to be the gold standard labels, with these accompanying text responses. And this approach gives us a labeled psychometric NLP testbed. The testbed and code we use to evaluate our data construction are available on our Human-Centered Analytics Lab's GitHub page shown at the bottom here. While we focus on the health domain, we believe our construction approach is broadly applicable. In total, we collected over 8,500 quality user responses from Amazon Mechanical Turk and Qualtrics. For each user, we have 4 psychometric dimensions: subjective literacy, objective numeracy, trust in physician, and anxiety visiting the doctor. We also have text comments from these 8,502 users for each of these 4 psychometric dimensions. And finally, we have self-reported demographics such as age, race, sex, income, and education. Before explaining the testbed and our evaluation, I'd like to take a moment to highlight some of the unique aspects of our testbed. First, while psychometric dimensions such as sentiment, emotion, affect, and personality traits have garnered a fair amount of attention from the NLP community, there's been limited work on constructs such as trust, anxiety, and perceptions of literacy. Second, the combination of survey, text, and demographics could allow advanced NLP-based user modeling, including multitask learning and other types of psychometric NLP. And third, by including multiple demographic dimensions, the testbed presents lots of opportunities for research on fairness in NLP. where known demographics of the source of text are often not available. Regarding the four focal psychometric dimensions, let's briefly just touch on what those are. The first one, subjective literacy, is essentially how much one thinks one knows about health and access to health-related information and providers. The second is objective numeracy, and this relates to one's ability to calculate, use, and understand numeric and quantitative concepts in the context of health issues. The third is perceptions of trust in physicians and doctors. We've already talked about this one a little bit, and these are important for downstream health outcomes. And finally, anxiety when visiting the doctor is also important for things such as future doctor visits and wellness. Now, in the paper, we provide examples of the survey items, the score distributions, and sample text responses. So one of the neat things about our testbed is that we intentionally used Amazon Mechanical Turk and Qualtrics to ensure greater demographic diversity in our data. For example, in terms of age, the average age, or the mean, is about 40, and 28% of the users in our data set are over the age of 50. Similarly, in terms of race, about 1/3 of our respondents are non-white. In terms of sex, 2/3 are female. With respect to income, about 63% reported an average income below $55,000 US per year. And in terms of education, about half have a college degree. And where we think this is especially important is in fair NLP research, where coverage for protected class attributes, such as the elderly, underrepresented racial minorities, women, lower income groups, and groups that are less educated, is incredibly important. So we can examine the disparate impact of our NLP-oriented AI and machine learning. So in order to demonstrate the efficacy of our testbed, we performed two types of modeling tasks. In the first, we used existing NLP methods to predict and classify the psychometric dimensions based on the text. So this is kind of in line with prior work published in ACL and EMNLP on how to evaluate a constructed testbed for text sequence classification, essentially. And the goal is to show that the testbed is reasonably constructed. The second task was to illustrate how this testbed can be used to study fairness in NLP. So in our first evaluation, we evaluated our testbed as a continuous prediction task. Here are the distributions related to our four psychometric dimensions, or DVs, on the 0-1 scale. And the task is to predict these scores using fivefold cross-validation across the 8,502 data points. And the purpose, as I mentioned, is to show that the data can be modeled by state-of-the-art NLP methods, but at the same time, to show that the task is non-trivial. By non-trivial, we mean that there is room for future improvement. If the results are too good, of course, the psychometric NLP problem might not be as scientifically interesting. In other words, we want to show that the testbed is in that sweet spot for modeling, with potential for modeling and potential for improvement. So we evaluated 5 comparison methods. The first was the BERT-based model, which was fine-tuned on our training data. Next, we have our word LSTM and word CNN, both trained on the glove word embeddings. And finally, we include 2 feature-based baselines, the feed-forward neural net and the linear regression, which each use up to 50,000 word unigram, bigrams, and trigrams. And these details in the model setup and the parameters can be found in the paper, and we've also included the Python code for each method on GitHub. So here's table 4 of our paper, which shows the results. The methods are arranged somewhat in the order of how we would anticipate them to perform based on prior text sequence classification NLP literature. In other words, the transformer model being the best, followed by our LSTM and CNNs, which in turn outperform the feature-based methods. And generally speaking, that is exactly what we observed. Right? Additionally, our R-square values of around 0.5 and 0.6 for the best methods and the root mean squared errors suggest that the testbed is in that appropriate sweet spot of being meaningful and non-trivial. As we discuss in the paper, these metrics are consistent with recent testbed studies presented at ACL and EMNLP. We also performed a classification task and those results appear in Table 5 of the paper. As noted, one of the nice features of our testbed is that we've included rich demographic information. This can be used to evaluate the fairness of different NLP models. Here's the formula for disparate impact. It is essentially the ratio of positive predictions for non-privileged group relative to the positive predictions for the privileged group S. In our case, if a numeracy prediction model has a DI of 0.8 for numeracy classification, in the case of authors that are non-white versus white, this means that our model is 20% less likely to consider non-white text as being high numeracy relative to text from white authors. In general, we want our DI to be around 0.1, which means we have no disparate impact. So when you look at the results here, which are in figure 4 of the paper, and we do examine other fairness metrics in the paper, you can see that in our case, that 0.1, that 1.0 line is right there, and we're seeing the results for BERT, word CNN, and our feed-forward neural net. And in many cases, we are close to that 1 line. However, there are a few cases where our models have disparate impact. For instance, BERT has a DI much less than 1 for numeracy. And there's 3 models, and that's shown right there. That's the numeracy result. And then we have 3 models for anxiety. All 3 of them are 5 to 10% below the 1 threshold. So we have some disparate impact in here. And of course, this is just a small analysis of fairness. Clearly, it shows that we have a lot of work to do in better understanding bias and debiasing our NLP models. So kind of in conclusion, if you found the talk interesting, we encourage you to read the paper and download the testbed. We think NLP is important, psychometric NLP is important for better understanding the human condition. We need more work on constructs like trust, anxiety, and literacy. We also believe that NLP is critical for user and behavioral modeling, which is at the intersection of text, surveys, and demographics, precisely what this testbed provides. And finally, recent papers on fairness and NLP suggest we should explore these issues in real-world social contexts with clear normative goals and reasoning. And other work has noted the importance of exploring intersectional bias across multiple demographic characteristics. We think this testbed is one of many needed steps in that direction. We hope you enjoyed the talk and that you'll find the testbed to be useful. Thank you.